Now let's look at maybe the hardest case here where you could get two possible triangles with given information, and we can see how the law of sines helps us to do that. So we have these three pieces of given information, and since the other b is missing, we'll look for angle B first. So I'll set it up as the sine of angle B over side B equals the sine of angle A over side A, and solve for angle B. So I'll multiply both sides by 9 first, and then I'll take the inverse sine to get B by itself, and we get 18.1 degrees, or we have to consider the supplement to this because we're using sine inverse, 161.2 degrees. So we have two possibilities for angle B at this point. Let's label them B sub 1 and B sub 2. Alright, so at this point we're going to take two different paths. This is going to be triangle 1 that we're going to look at over here, and over here this is triangle 2. So we have to consider that both of them are possible unless proven otherwise. So if angle B is 18.1 degrees and angle A is 14, then angle C, or C sub 1 to match B sub 1, would be 180 minus the 18.1 and the 14, which is 147.9 degrees. So we have all three angles now. We have sides A and B, so now we need side C. To find side C, I'll set it up as side C over the sine of angle C, and notice I'm using C sub 1 here because this is triangle 1, equals, we know angle C sub 1 is 147.9, equals, let's use the A's that we were given, so side A over the sine of angle A, and to solve for side C sub 1, multiply both sides by the sine of 147.9. And that gives us approximately 15.4. So we have all three missing parts for this possibility for triangle 1, and they all make sense. For example, the largest angle is opposite the largest side. The smallest angle is opposite the smallest side, and the angles add up to 180 degrees. Let's come over here and do the same thing for triangle 2 and see if it's a possibility. C sub 2 would be 180 minus the 161.2 minus the 14, and we get 4.8 degrees in this case. So now we know angles A, B, and C, sides A and B. Let's find side C. So to find side C, we use side C over the sine of angle C equals side A over the sine of angle A. To solve for C sub 2, multiply both sides by the sine of 4.8 degrees. And we end up with approximately 2.42. So now we have all three sides, side C, side B, side A, for this triangle, and we know all three angles, angle C, angle B, and angle A. The largest angle is opposite the largest side now. The smallest angle is opposite the smallest side. And all three angles add up to 180 degrees. So we get two possible triangles out of this information, but both triangles have in common the same given information.